And that is the only time in my entire life that I felt like a bad person. Please don't share that. Okay, so welcome back, Calcsters. Today we are looking at this. I told you a minute ago before I started recording, what's the very first thing we should always try with a limit? Substitution. Let's try it. So if we try and it fails, that's awesome because it just means we get to do more exciting stuff. I'm going to try 5. If I try to just plug in 5 and I'm actually plugging it in, I would lose the limit symbol because I would actually be doing it. So let's try. This would be root 5 minus root 5 over 5 minus 5. Oh, where? Uh-oh. Well, shucks. Okay, we're going to clean up language. We won't see this for like 6 chapters. What is 0 over 0? It's not undefined. Not anymore. We're going to have a better word. For our purposes, it is, like this does not exist. The new word, when we encounter this, is indeterminate. So here's the weird thing, and we'll see this literally in like 6 months. 0 over 0 could be undefined. Sometimes it's 1. Sometimes it's pi. Sometimes it's -7. Like, it's indeterminate until we do the problem. Okay, we will learn how to deal with that. Undefined is a fine thought for now. In either way, either case, did that give us the value of the limit? Well, shucks. All right, so this is the first time we've ever had to do this. I gave directions on your bell ringer today. I asked you to do something without looking at your bell ringer. What did I ask you to do? Rationalize. Now, normally, every time you've ever rationalized in your career, it's been rationalizing the denominator because we've trained to do that so the unit circle looks the same no matter where you go. Cool. Is my denominator in need of rationalizing right now? No. No, like it's good. Here's the cool thing. Rationalizing the denominator is only a stylistic, like let's make stuff the same for everybody kind of thing. We don't have to always. In fact, we're about to see a new approach here, and I'm going to ask you guys, because we just did it on the bell ringer, before you take the limit, here's what I want you to do. I want you to try to rationalize, not the denominator this time, but the what? I want you to rationalize numerator. Now, before I say you guys just do this, I need to make sure we all agree. What is the conjugate of the numerator? Hit it. Root x plus root 5. What's the only thing I can really multiply by that doesn't change stuff, though? 1. So if I multiply the numerator by root x plus 5, the denominator must also be multiplied by what? Root x plus 5. So when you're writing this, you are going to do the limit because we haven't done it yet. We'll take the limit as x approaches 5. And then I'm going to use brackets just so it looks a little nicer. We have this lovely root x minus 5, or minus root 5, I'm sorry, over root x, x minus 5. And we're going to multiply it by what again? Root x plus root 5 over root x plus root 5. So here's my challenge for you. I want you to do this, just this part. Once you get to an expression where we've rationalized the numerator, we still haven't done the limit, we'll meet back up. I'm going to give you guys a second, practice your algebra, rationalize, do this multiplication, FOIL it out, use scratch work if you have to. Cool. I'll walk around, so if you need help, go. Okay, so looking at this, I haven't done the limit yet, so I will go ahead and keep working. I'll switch back to my red color. I like that red because it's a little darker. Okay, we will take the limit here in a second because we're just rewriting stuff right now. In the numerator, if you have something times its conjugate, those middle pieces will always fall out because one of them will be minus, the other is plus. What's the square of root x? Minus, what's the square of 5, or root 5, sorry? Cool. Is that everybody's numerator? Boom, easy. We don't really have to think about it. If you did want to think about it or you're struggling to, do you guys have an electronic device that could do this? Your calculator. I would be worried about using root x because it'll think you're using a variable, but let's check because I want you to do it without the calculator as well. So let's FOIL out the denominator. When we FOIL, what's the first thing that we have to multiply? X times what? So check me out. X root x. Don't care what it simplifies to. I'm good with this. How about the next piece? So there's the firsts. How about the outsides? Plus or minus? plus x root 5. The next piece? Minus 5 root x. And the last piece? Okay. It likely goes against all of your instincts to not clean this up because you've always cleaned it up. Are you guys okay with noticing that we just haven't? Okay, is this easier than actually doing the FOIL? Easier for me. It saves a lot of time with the simplifying. We don't have to simplify in here. That's a really handy thing. We will keep this year 3/6 instead of going to 1/2. Okay, as we look at it, I have rewritten everything in here, but have I really changed anything? Why not? I multiplied by 1. This looks wildly different. That's it. It just looks different. So now that we've rewritten it, let's try something. I want to see if we can use direct substitution now, which means anywhere in this thing that there's an x, what am I going to replace it with? 5. So the second I start doing my direct substitution, I've actually done this operation of the limit. I will not write limit again. So let's just see what shakes out. Anywhere that, I'm not going to change colors. Never mind. So let's see. In the numerator, we're left with 5 minus 5, right? Okay, let's look downstairs. We get 5 root 5. Everybody's cool there. 5 root 5 plus 5 root 5 is the second one, minus 5 root 5 minus, did I write x? Why did I write x? 5, sorry. Minus what? 5 root 5. Okay, does it really feel like we've changed anything? Not super yet. So as we're digging through, did our limit work this time? I'm going to give you guys a second. Chat, see if we've really changed anything. Go one step further with cleaning it up and see where we wind up. I'll give you like 30 seconds because we're pretty much there. Ooh, JJ has a good observation over here. You say that super loud, JJ?
We still end up with a 0.
We still wind up with a 0. Well, what do you think we could possibly do? Is the numerator still 0? Yes. Is the denominator still 0? Yes. Okay, so here's the big challenge, and this could have been on purpose. Where's the mistake in our math? So I'm refoiling out the denominators, what I'm looking at right now. We have x minus root 5. Or if I wrote it down, that was the other possibility. But I would never do such a thing. Shout out if you see it. We're going to dig through it for a second. I don't have the answer on my page. I'm just seeing if I wrote down the original problem wrong. Did I completely write it down wrong? If so, we'll be okay. But we're going to see. You guys are just helping me find mistakes right now. Root x minus root 5 over x minus 5. That's where we started, right? Oh, I love it. Oh, man. Hit it.
I think it's because we build the denominator where you can cancel out the numerator and denominator.
Gosh, is there something that we can cancel out? Because you're absolutely right. There's something that divides out in here. So here's a really important part of this. When you encounter issues like this, does it mean that we've completely lost it? Okay, we're going to dig way deep. We're going to come back to this one. I want to do another example. Leave like 2 or 3 lines. We won't need much to be able to clean this up, but we're going to make a slightly easier example. And we'll come back and see if we can apply it here. So I'm going to leave this much space for mine. We're going to come back to it, and let's see if we can't find one that's maybe a little bit nicer to look at. Okay, one more, and this one will be easier. Cool. This is D, right? All right. Let's do D, and I'm going to let you guys push through this problem, and we'll see how we can apply what we've done here to the next. So I want us to take last limit here for right now, and then we'll get a bunch of time to practice stuff, because we're just doing practice today. I want the limit as x approaches 9 of, let's say, the numerator, we have x squared minus 81. And we're going to divide this bad boy by root x minus 3. Now, I would like to do this as a big group, but I'm going to draw from your guys' knowledge and thoughts. First thing we should always try on this. Direct sub. I'm going to try to plug in 9. What's the numerator? 9 squared minus 81. 0 over root 9 minus 3. 0. Shucks. So, slight different problem here, right? Last time we rationalized the numerator. Does it look like we're really going to rationalize the numerator here? No. Could we try to rationalize the denominator? Absolutely. Hold off, though. I want to see if there's anything else that we could do. Example B that we worked, or A yesterday, we saw two techniques. We always tried direct sub. If that doesn't work, what was the other one we tried? Check your notes from yesterday. We did like 2 examples in class. Direct sub sometimes works. If it doesn't work, it's an F word, I think. Factor and see if it divides out. And if that doesn't work, the third technique that we've seen is rationalizing. So, our goal right now is we're going to see if we can factor. Does anything here factor? So you say 3, but let's be more specific. Does the numerator factor? How? Okay, so in the numerator we see a difference of squares. I'm going to rewrite the numerator x minus 9 times x plus 9. Are we still on the same page? Okay, now down here we still have a root x minus 3. Okay, we're going to see something that feels unnatural. I wrote root x. It's just, yeah, it is root x minus 3. Okay. Suggestions. We're going to take whatever step. If it's a wrong step, we'll figure it out. I'll try to guide us to the right step. What might we try to do? Based on the last example, what do you think I'm expecting you're going to say? We could try to rationalize. Could we try to rationalize? We could. Do you want to? Okay, what would you multiply by, Fern, if we did? Root x plus 3. And we could multiply by root x plus 3 over root x plus 3. Now, that's always a good thing to try, but because our last one ran into trouble, we're going to look at something that's going to feel weird. You guys recognize differences of squares, right? Okay. Do I have any more differences of squares up on the board on my second line of work? So, how many of you gut feeling? I saw Angel said no, which is what I was expecting. I don't see any more really obvious differences of squares, right? Are there some less obvious differences of squares? Do I have a difference in the numerator? Is it a binomial? Do you know the square root of x? Root x. Do you know the square root of 3? Sorry, 9. Could we factor this then as a difference of squares? Help me out here. Let's try it. So, just like we did with the other one, with a regular old difference of squares. If I wanted to, and I'll zoom in on this one so we can see it, I'll just circle this. Gosh, that's a difference. And I could take the square root of both of them. It'll be ugly, but I can. How would this factor? Root x minus 3 times what? Root x plus 3. Oh. And then nothing else has changed, right? We still have x plus 9. We don't have a sum of squares because we would have complex numbers. And we have root x minus 3 here. Now, looking at this, I'm pretty sure that Miss Cabal, is this what you were referencing? A moment ago when you said you could rewrite. Okay, love it. Why would I bother to do this? Why is this an okay approach? I don't know they don't. That's not the word we use. So you're right. They do cancel. And you're probably so set in your ways, but I'm always going to pick on you for it. Something divides out. What falls out? Have we changed anything other than the way this thing looks? No. We just factored and divided common factors out. we now have a new limit in front of us that's essentially a new problem, for lack of better language. What's always the first thing you try? Well, try it. Let's see what we get when we direct sub after we've used this handy little trick. The second you do direct sub, you do not write the word lim again. No more limit. I'm sorry? Oh, there's no denominator left. Gosh, that seems pretty handy. When we plug in, anywhere there's an x, what gets replaced with it? So this becomes only a numerator anymore, and we get root 9 plus 3. That's this set of parentheses right here, times 9 plus 9. Well, what's root 9? 3. So 3 plus 3 is 6 times 18. What's 6 times 10? Plus, what's 6 times 8? And 60 plus 48 is 108. Now, for practice sake, this problem felt challenging. We did a slightly different approach. We're going to come back and see if maybe there's some places in here that we could do to make this problem easier as well. But now we have a new tool to look out for. That rationalizing is always a good thought. There's differences of squares hiding all over the place. And I know, looking back at it, I can see where the issue here is. But I want you to check on your calculator as well. I will lend you mine for now. And I'm trying to find one that has batteries that work for you specifically. All right, who's confident with your calculator? You've never used a calculator like this. Is yours dead? Okay. What are you doing? Ooh, okay, so black screen. All it means is the contrast has changed. So if this ever happens, did you have the cat on your bag? So that's okay. So diamond or second. One of these have changed the contrast. So it's darker or lighter. Up and down is what you're gonna play with on this. So change the brightness. So I didn't know which one. Which one you think is brighter. Oh, it's very good. So I'm hitting diamond and down to turn the contrast down. I'm just gonna take a bunch of clicks because it looks like you got stuff in your calculator or in your bag, which that's okay, that happens. Maybe alpha. Yeah, you're gonna hit seconds or diamond and you're gonna change that brightness all the way down. Thanks for listening. Okay. All right. So for those of you that may not be super comfortable with it, Delilah has confirmed we do indeed get 108. But let's check it out and typing it in. Now, the typing it in part sucks. The pretty print makes it nice to see if we have the right thing or not. But here we are. We're going to do some calculus on these lovely TI-89s. But here I am and kind of embarrassed. I don't remember how to get to any calculus in here. Oh, I'll just use the tabs on top. F3 is calc. F3. Are we differentiating right now? No. Are we integrating? No. Are we taking a limit? Yeah. Boom. I hit number 3. Now, if I want to have a lovely rational expression, what has to go around the numerator and the denominator? Parentheses, and I don't see the function anymore, but it was x squared. You have to use the caret. Minus 81. That's my whole parentheses in my numerator. Divided by, what was in the denominator? Root x minus 3, right? So check it out. Really, really important that you do this. What do we put around the entire numerator and denominator? Parentheses. So I'll start a parenthesis for the denominator. The square root is on the right side where multiply is. The square root of, what do you think I have to put here after I put that x? Parenthesis, because it's saying, hey, put a parenthesis around whatever you want me to take as the argument of this radical. Okay, minus 3, parenthesis. I now have the denominator. If I hit enter right now, why won't it give me the answer? Yeah. I haven't told it what the variable is, nor have I told it what we're approaching. So let's go ahead and add that. I'll go 1 back. What's the variable we're using? And how do I tell the calculator that, hey, let the limit as x goes to some number? Comma above 9. And to what number is x going? 9er. Let's see if we got this typed in. Too few arguments. I forgot a comma. Hey. It is 108, and I agree with it. Cool. So, as we look back at the other problem, before, I want everybody to get a chance to type this in. Here is the terrible, ugly key for key that you can see on the screen highlighted right now, but I want everybody to show me that you can type in this limit on your calculator. Don't clear it once you do it, because I'll make you type it in again, but I want to see everybody do it. Yeah, well, I'm going to keep this up here so you can see what I've typed in. Love it. Okay, weird stuff.
Oh, so busy.
Last one. Shibuya roll call.
Square.
Okay, just a reminder, when am I available for help?
Number one was.
Before school, always at lunch. I'll always make myself available. You might have to meet me at the teacher's lounge, but I'll be available. Or after school. I don't know if any of you guys are big football fans in here. What days of the week are there not NFL games on TV? Tuesdays, Wednesdays, and Fridays, but there's never study hall on Fridays. Tuesdays and Wednesdays, there's no football. What days do you think I'm going to be here doing study hall until 4:30? Not Monday. Monday night football, Thursday night football, Tuesdays and Wednesdays, I'm here till 4:30 for a study hall. Very specifically chosen so that I can watch the Dallas Cowboys lose. All right. Forget your glove or did you catch it? All right. So, looking at this, I might have lied to you guys because I came in a little bit confident. I didn't look at my notes even a little bit before, and I might have misrepresented one little thing. We haven't done anything wrong, just so you're aware. Okay. Anybody not able to get this on your calculator? Cool.
I could.
Yep, so you missed the whole calculator day.
Yeah.
I will get you practice with it. Okay, so let's look back at this one. And I'm going to make one little suggestion. Could we, right off the bat, have done something similar? How? So I'm going to pretend, again, I don't like erasing because then we avoid mistakes. We haven't really truly made a mistake, but our goal is efficiency, and I think we could do it a better way, especially after just doing that last one. So we're going to get rid of this. It's not wrong, but we're not going to take that route. We're going to get rid of this. It would work, but I think there's an easier way. Right off the bat, is there anything in the numerator of our original C that we could have factored? So I'm going to ask a much more specific question. Two questions in the place of one. Is there a nice difference of squares in this argument? There's not a nice one. Is there an ugly difference of squares in this argument? Do you know the square root of x? Root x. Do you know the square root of 5? Root 5. Is it a difference? So let me try this one more time. Is there a difference of squares hiding here? Absolutely there is. So if we had jumped in this problem and thought about factoring to help us rationalize a little bit, the conjugate will take us down the right path, and we will see an example where we do that. But let's try this again. I need help factoring, though. The numerator is going to stay the same. My argument still has a numerator of root x minus root 5. Here's the big question. Using these fancy factoring techniques that we've typically said didn't work here, they do, they're just ugly. How could I factor the denominator? Bless you. Okay, I'm going to give you 15 seconds to chat with your neighbors. I'm going to call in somebody random. How can I factor this denominator? 15 seconds from right now. That's me saying talk, not being a lobster. JJ, your new number in here is going to be 13. So your phone will go in slot 13 when it's fine today. When I call on random numbers, 'cause that's what I'm doing now, if number 13 calls up, it's you. Okay. All right, that was 15 seconds. Number 7, who dat? Hey, Sean. How do I factor this? Oh. Why am I saying oh with the inflection that makes me seem like I'm like super psyched about this? Cha-cha! What's in the numerator? Not 0. 1. We 1 out, right? We divide out. I now have a new limit. Different problem. Same thing. We haven't cheated anywhere. What should we try now that we have a new limit? Give me the real word. Direct substitution. Let's try it. If I direct sub, do I need to write the limit symbol again? Nah, we done with it. What's the limit as x approaches 5 of the numerator? Is there an x here? So no matter what x approaches, what is the numerator always going to be? Okay? In the denominator, we would get a root 5 plus a root 5. What's root 5 plus root 5? 2 root 5. They don't just add up the way you want them to. It's like x plus x is 2x. So we get 1 over 2 root 5. Can I stop here? Nope, we're stopping. This is it. I'm done here. Do not rationalize it. Now, would you like to see where I made a mistake on the rational other direction? It's not really a true mistake. Whether you like it or not, you don't have to write it down, but I am going to show you. At this point, I said don't multiply it out, right? And then what did I immediately do? What shouldn't I have not done? I shouldn't have even foiled at all. I even told you guys, let's not multiply it, and then I immediately did that. If I didn't actually multiply it, and I am going to erase just in the interest of saving time, what would my denominator have been if I never multiplied it like we had agreed to not do? X minus 5 times. If we hadn't multiplied like we had agreed, would something similar have happened just now? 1 over root x plus... Okay. Wow. Wow. I don't do a good Owen Wilson. I'll break my nose tonight. All right. Feeling okay? Feeling awful? Ready for a hard one? Cool. We'll see. We did that. We got 10 minutes. We're actually not going to do another example right now. Not yet. But we are going to introduce the last topic of this section 1.2. So, in here, I don't remember what they are. Yesterday we saw all the limit properties. You have a big list of them. I will hook you guys up with some flashcards. You need to memorize them. Today's Tuesday, right? Now, I think by doing them, you'll memorize them. But just on the properties, we listed like 10 yesterday. Friday, there's going to be a quiz on the properties where I give you the limit and you just tell me, how does this change? How does it expand? Those 10 things. I will make you flashcards. Or you can make flashcards. Friday. 5-minute quiz. Show me you know these properties. Cool. You have all the answers in your notebook from yesterday. Cool. All right. You say it like some of you look really scared, but the limit of a product, if you can say that, you're good. You're going to get an A. Cool. All right. So, last main topic, and then we get one kind of interesting additional topic that we look at. When we talk about slope, what is slope? Rise over run. Give me another way to say it. You probably learned it. Delta something. Delta y over delta x. Now, in calculus, we often worry about slopes, and specifically we'll refer to them as tangent lines. And the slope of a tangent line, it's called a derivative eventually. But we worry about slope because all that says is how fast does something change, which is like the real value where math starts. If you're flying a rocket to space and you're going to burn fuel and you can calculate and see how fast you burn your fuel, well, I want to know when it gets to 0 and how fast it's going to start changing through different air densities and stuff. There's immediate obvious application to where this applies. For here, we jump in before we get to the calculus. I'm going to write this word once, and then we will only use a acronym. Is an acronym just the letters? So there's acronyms and then there's ones that make words. Either way, we'll use it. We're going to talk about an average rate of change. And we're going to do this in the really general, pure mathematical sense. You will never see me physically write the words average rate of change ever again. Never. Anybody recall what the shorthand is? Or if you got to shorthand this with 3 or 4 letters. So close. I don't call it arc because that's a specific part of a circle, but I call it AROC. Average rate of change. AROC. Okay, if you want to write average rate of change, you do you. I'm lazy and I don't like to write. So here we go. We are looking for an average rate of change. We're going to use a picture for our definition. and there won't be many words. So I'm going to graph in quadrant 1, and I'm going to have a bendy curve. So it'll probably look like part of a parabola, but I want to make sure it's pretty bendy. Boop. Here it is. And that's F. It's beautiful. Okay. On this, if I pick two x values, and I don't care what they are, I'm just going to arbitrarily place them. No thought put into this other than the fact they're in quadrant 1. I want this to be A right here. And then somewhere over here, we're going to put point B. Okay. When I go to that x value, and then I plot a point on my graph at that particular x value, can you tell me the y value of each of these two? Like, what's this y value up here? F of B, and this one is F of A. Everybody cool with that? On this graph, and there's no context, this is just the pure mathematics that we're looking at right now. On this graph, from A to B, do you think on average it increased or decreased? It increased. Why do you think that? Because it went up. Like, there's an obvious answer to it. You're not wrong. Your intuition's perfect there. Now, could I draw a line between these 2 points? It won't be a tangent line. It'll be a what line? The secant line. So, turns out, super easy to define this. I'm going to draw that secant line. Just a single line that crosses through both of them. And I'll switch colors so it doesn't look like my axes. Okay. Here we go. The average rate of change, AROC, without words, we're just going to write it out. AROC. Turns out for any function, the average rate of change on an interval, which we are working from where to where along the x-axis. So the average rate of change for any interval, a to b, for any function, we call ours f, is simply the slope of the secant line. So I'm going to use our standard notation, m for slope, and I will use a subscript of secant. And then we're just going to plug in our formula. You guys told me that slope is rise over run. I'm good with that. It's also delta y over delta x, or y2 minus y1. Like, there's a bunch of different ways you've seen it. How would you calculate from this picture with, you can't give me numbers, but what are the two y values? F of b and f of a. Could I find the difference between them? Does it matter which one I put first? If I write f of a minus f of b, it'll probably annoy you. Why? Maybe it won't. Does this not annoy anybody if I do it like this? It's okay, but what's annoying? Yeah, the order. You want the bigger number first. So we will stick with that normal convention. I want to know the change in y. It's this, f of b minus f of a. Over, the second we commit to this order, what has to go in the denominator? B minus a. If we had done f of a minus f of b, we would have to adjust for that in the denominator as well. This is it. This is the average rate of change. Now, super easy to deal with. We're going to do one quick example of this. I want you to find for me, consider, and we'll just do one example. Consider the function f of x equals, I don't know, what's your favorite function, Fern?
X squared minus 9.
Fantastic. So many f's. X squared minus 9. Okay, so we have a lovely parabola. I want you to find, I'm going to write a rock, but what does it stand for? Good. And 4, and you guys are going to have to help me with some shorthand. X, what is this thing? In the set of. Now, we could think of it in the set of or in the interval. In this situation, it's going to be an interval that we're thinking of, but an interval is just a set. And I want x for, let's say we run from, I don't know, -3 to 5. Now, the language looks like it's different, and obviously I use slightly different language, but the concept's the same. I want to know the average rate of change between which two x values? From 3 to 5, that whole interval. Could you find me the slope using this formula, but applying this function and these x values? Do so. Find me the average rate of change here You may see this worded, I'm just trying to introduce. If you look at this and go, what, and your brain freezes, the other language that I'll just put beside this, from x equals -3 to x equals 5. This is the same statement in this interval from these x's. Cool. Calculate that for me. You have like 70 seconds. I think you'll be able to do it before you leave.